We now use biofeedback in several lines of our lab's work, and certainly one of those is to better understand the biomechanics of movement in older adults. And as a bit of background, many individuals, whether it be due to advanced age or gait pathology, suffer from insufficient push-off during walking. And because a burst of ankle power during late stance is a very economical way to power walking, this change is thought by many to contribute to a decrease in walking economy, accelerating fatigue, and a reduction in walking speed. The challenge there is that it would be incredibly difficult in an observational study to show a cause and effect relation between insufficient push-off intensity and higher metabolic costs or slower walking speeds. But biofeedback can actually overcome those challenges. So here, while participants walk on an instrumented treadmill, let's go ahead and extract the peak anterior or propulsive ground reaction force as a measure of push-off intensity on a step-by-step basis, while subjects use real-time biofeedback to target values 20 and 40% larger and smaller than preferred. And you can see here that subjects are quite good at matching these target values in different trials. We'll then record expired gases using indirect calorimetry and estimate group average changes in net metabolic power, which you can see here. So in the red, pushing off the ground with more intensity costs you more metabolic energy. That's not surprising. However, an insufficient push-off, shown here in blue, is actually equally, if not more expensive. So here we see clear evidence that walking with an insufficient push-off actually increases metabolic cost. And in follow-up studies, we've used musculoskeletal modeling and simulations to identify the reason why, and show that an insufficient ankle push-off, you need more active work performed by proximal and less economical leg muscles, particularly during early to mid stance, which you can see here. And this comes with a significant metabolic penalty. And these are hallmark changes due to aging. Now, as I mentioned, an insufficient push-off is thought to produce slower walking speeds as well. However, there's actually no empirical data showing that cause and effect relation. In order to provide that insight, we had participants use the same type of propulsive force biofeedback, but now they're going to do so while walking on a treadmill under self-paced control. And you see the real-time estimates of speed over the course of time for those trials, and we see definitive evidence that an insufficient push-off causes you to walk slower. And these are just a few examples about how biofeedback has helped us to understand the metabolic and functional consequences of reduced push-off intensity in older adults.